All right, we got 11.2 areas of regular polygons, and we are going to look at a few different formulas, and we're going to pull out our old friend sine from sine, cosine, and tangent as well. Let's take a look. All right, first of all, we're going to deal with a triangle, and remember a regular triangle would have all sides equal and all angles equal. And so that would make it an equilateral triangle. Well, there is a nice formula for an equilateral triangle for the area, and that is 1/4 the square root of 3s squared. And we'll get to this when we look at an example, but notice that the square root does not go over the s squared. So be careful about that when you're putting this into your calculator, that you finish up the square root of 3 with either parentheses or move the arrow out of the square root depending on your calculator, and then put in the s squared. We also have an area of a regular polygon, and this would also include a triangle if you want to use this one instead. But the formula is half n r squared sine 360 over n. N stands for the number of sides, just like in the last section when we had an n, that was the number of sides. And R stands for the radius, which is from the center of the polygon to one of its corners. And here's an example over here of a hexagon with all these sides here. So this hexagon, the R is from the center of the hexagon to one of the corners. So it's the length of that. And for a hexagon, that length is actually the same as its side length, but only for a hexagon. That's not true for any other shape. But in this one it is, because it makes you can see it's equilateral triangles. Here's an equilateral triangle here. So anyways, R is from the center to a corner. And then n, in this case, will be 6, because there's 1, 2, 3, 4, 5, 6 sides on the hexagon. That's the area. The perimeter is 2nr sine 180 over n. So a lot of similarities between the two formulas, but also enough of a difference to make them a little bit different. We've got half on the area and 2 on the perimeter. On the area, the r is squared, but perimeter is not. They both have n's though. They both have sines. And on the area, it's 360 over n. Perimeter is 180 over n. But the letters are the same. N is the number of sides, and r is, once again, the radius, or the distance from the center to the outside point. Okay, we've talked about that. Radius of a regular polygon is the segment from the center of a polygon to a corner. So right here it's G to B. Another thing is called the apothem, and that is not in our formulas, but sometimes it's one of the terms you need to answer some worksheet questions. The apothem is a segment from the center of the polygon to the midpoint of a side. All right, so in this diagram up here, it's from G to H. That's called the apothem. And the midpoint also makes a 90-degree angle for regular polygons too. The central angle of a regular polygon is the angle formed by 2 radii of a regular polygon. And so in this diagram, angle BGA, so this angle right here, is the central angle. And you remember that from our circle lessons in our last chapter. The central angle was at the center of the circle. Well, same thing here. The central angle is at the center of the circle that can be formed that's going around the polygon, but it's specifically, in this case, being formed by the 2 radii made from the radius of the polygon. The formula for that is theta equals 360 over n. All right, let's put our formulas to use. Most of these are just going to be, you take the formula, you plug in n and r, or in this case s, plug in your letters, and then work it out. Okay, so this one we've got an area of an equilateral triangle. So that's in our notes, 1/4 square root of 3s squared with 8-inch sides. So 8 is going to go in for the s, like so. And you can put this in your calculator. When you're putting it into your calculator, do make sure that you finish up the square root. The 8 squared is not inside the square root. That's one common error that I see when I'm teaching this. So you have 1/4, that's 1 divided by 4. Then you do a square root on the graphing TI calculators. That's on the left side. If you press second, x squared. You can put a 3 inside the square root, and make sure that on some of the older calculators you need to close up your parentheses afterwards. Some of the newer calculators actually has the square root line going over top. You just need to press the right arrow button to get out of it so that the 8 squared is not underneath the square root. And then you type it in. If you do it right, you should get 27.71. Okay, so try the same thing with an equilateral with sides of 5. So go ahead, pause the video, put it in the formula, and see if you get it right. Once you have it, resume the video. All right, so our equation is 1/4 square root of 3s squared. S is 5. And we should get 10.83 when you put it in the calculator. If you didn't get that, make sure that the square roots is finished up after the 3, so your 5 squared is not part of the square root. In fact, if you're having trouble with that, you could just get the decimal for the square root of 3, which is like 1.7 something. Get a few more decimals than that though, and then do 1/4 times that 1.7 times 5 squared. That might be more helpful if your calculator is messing up for you. So anyways, you should get 10.83 for your final answer for this. Okay, example 3. We've got a regular pentagon. So it means I can use the next two equations in my notes to find the perimeter and the area. It says the radius is 1 unit, so that makes r equal to 1. And since it's a pentagon, pentagon has 5 sides, so n would be 5. Okay, so our perimeter formula is 2nr sine 180 over n. And our n would be 5, because it's a pentagon. R is 1, because that's given. We got sine 180, n is 5 again, so over 5. Make sure you're in degree mode on your calculator if you're still using it from back in chapter 9 and no one borrowed it. You should still be in degree mode anyways. So when you plug this in, you should get 5.88. All right, and then for the area, it's the other equation, half nr squared sine 360 over n. N is 5 because it's a pentagon, r is 1, that's given, n is 5 for under the sine. So we have half times 5 times 1 squared times sine 360 over 5, and that should come out to 2.38 if that is done correctly. Okay, so you've got kind of the same question here. This time we have an octagon with a r radius of 11. So go ahead, pause the video, and find both the perimeter and the area. So you should have 2 answers before you resume the video to see if you're right. Okay, so the perimeter is 2nr sine 180 over n. In this case, n is 8 because it's an octagon. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, so n is 8 in both n places. And r is 11 because that is the distance from the center to one of the corners. So we've got 2 times 8 times 11 sine 180 over 8. and that should come out to 67.35 if you plugged it in correctly. Again, make sure you're in degree mode for this. If you're not getting that, and that may be the reason why. Okay, and then our area, half nr squared sine 360 over n. N is 8 once again, r is 11 once again, and plugging this in, you should get 342.24. All right, that brings us to the end of our lesson. All right, Sierra, can you explain that over again for everyone?
Yes. And this how does this is like minus 5, and we don't actually do that, and then we actually and yesterday's daddy's birthday.